This is example 4 in section 4.3. We want to determine the derivative for the function the square root of 4 plus 3x. So the definition of derivative is equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h. So the first thing we're going to do is determine what does f of x plus h look like. This is where you replace x with x plus h. So I'm going to get the square root of 4 plus 3 bracket x plus h. If I multiply that, I would get 3x plus 3h. So when I go back and write that within my definition, I'm going to get the square root of 4 plus 3x plus 3h minus the original function, which is given, square root of 4 plus 3x, all divided by h. So you have to think back to your algebraic steps involving limits and radicals. So if I substituted in h to be 0 right now, I would get a 0 over 0 type. So when we're working with radicals, we want to try to simplify, and we use conjugates. So the conjugate would be the square root of 4 plus 3x plus 3h plus the square root of 4 plus 3x. So that would be the conjugate. If you multiply it by the numerator, you multiply it by the denominator. And then I'm going to actually multiply out the conjugate pieces in the numerator, and I'm going to leave the denominator alone. I don't want to multiply anything out in the denominator because I want to see if this h will cancel. So the square root of 4 plus 3x plus 3h times itself, the radical will go away, and I'm just left with the trinomial. With conjugates, the middle terms cancel, and then I'm left with square root of 4 plus 3x, which I will get 4 plus 3x. All divided by h and the binomial radical, which is 4 plus 3x plus 3h plus square root of 4 plus 3x. Okay, so the goal is for terms to cancel. And I will get 4 subtract 4 will cancel. 3x subtract 3x will cancel, so I'm left with 3h, which is a monomial. And I'm left with a h with a monomial in the denominator, and I'm left with this radical that I'm not going to do anything with at the moment. Square root 4 plus 3x. Okay, so h's cancel, and I'm left with the limit as h goes to 0 of 3 over the square root of 4 plus 3x plus 3h plus 4 plus 3x. So now that I canceled my monomials, I can now use substitution to calculate my limit. So as h goes to 0, I know this term would go to 0, so I'm left with 4 plus 3x. There's no h term, so that means I'm just left with the 4 plus 3x again, which simplifies to square root of a root plus the square root of the same would give us 2 square root 4 plus 3x. And this is your equation for the slope of any tangent line for any x value.